In this lesson, we're learning the basics of how computers represent sound. Now, you probably know from your science lessons that sound waves are analog in nature. That means that they are continuous. Now, of course, computers are not analog. Well, the computers we're looking at aren't analog. They are what? Yeah, they are digital. So in order to record the sound and process the sound, then the computer needs to convert that analog wave into some kind of digital format. And we are looking at the basics of how that happens. So we will look at what's known as the sample rate, which is measured in hertz. I know it sounds painful, but in this case it means times per second. We're looking at bit depth, which is the number of bits that are used to store what's called a sample. And we also need to be aware that the duration of a sound is typically measured in seconds. So let's have a look at a slightly blown up sound wave. So here's a sound wave. We can see the amplitude. The amplitude is the height of the wave. So we have a sample frequency. So this is how often we take a sample. So each of these grey vertical lines represents when we take a sample. So the sample frequency is how often we take a sample, which is essentially means we look at measuring the height of the wave. So once we've got the height of the wave, we then need to store the height of the wave. And we do that using a number of bits. And the number of bits that we use is called, any idea? The bit depth. Right, so the sample frequency is how often we're taking a sample, and the bit depth is the number of bits we are using to record the height of the wave. Right, that is essentially how it works. So to go into a little bit more detail, how a computer records sound, so this is what happens. So in the case of me talking into a microphone, we have what's called an analog to digital converter. So at a particular sample rate, or sample frequency, I sometimes call it sample rate, sometimes call it sample frequency. So many times per second we measure the height of the wave, and then that is saved using a certain number of bits. Now the height of the wave at 0.05 seconds is found to be this very long number here. So of course this continuous number, it can't be stored on a computer because it'll be too long, it'll be too big, and needlessly too big as well. So we'd have to round it up to some extent. So we'll look at this number, we'll round it off, and then store it using an appropriate number of bits. So if it's a 16-bit audio file, it's going to use 16 bits to record that particular sample. Hopefully this is making sense. Hopefully this is making sense to you. It talks down here about bit rates. We don't need to be worried about that. So if we look at a typical audio file, so a typical audio file might be sampled at 44,100 hertz. So that means every 44,100 times per second, we take a sample. And we use, if it's a 16-bit audio file, we'll use 16 bits to record each sample. Right, so when you think about it, that is an awful lot of data that we need to be able to represent a wave accurately. So looking at the sample rates, i.e. how often we take a sample, and how does that impact upon the playback quality and the file size of a sound? Well, it's hopefully pretty obvious. The more often we take a sample, the more accurate the waveform is going to be. And the same with the bit depth. The more bits we use to record the height or the amplitude of the wave, the more accurate the representation is going to be. So yes, increasing both of those will increase the quality of the sound, but it's also going to drastically increase the size of the file as well. Now, of course, the human range of hearing means that we don't necessarily have to make the sample rate and the bit depth absolutely ridiculously big, because at a certain point, it doesn't matter how big it is, it's not going to have any difference to how we perceive the sound being played. So yes, increasing the sample rate and the bit depth is going to make the file bigger, is going to improve the quality of the sound, but it'll only be up to a point, and then there'll be a cut-off point where you won't be able to tell any difference at all. And this website here is quite good at getting that point across, because there's different settings that are used to play back this Coldplay track, and you can see, if you can see the difference between the different settings that are used to play back the file. So that is essentially all that there is. But what I will say about this is make sure that you clearly know a definition for sample rate. So if I was to say what is a sample rate, you should be able to tell me what it is. The same with bit depth in terms of sound. What does it mean? You should be able to tell me. Make sure that you can do that. And if you have any questions about this section, then let me know.